In this episode, we are going to make one of the most intimidating parts of early networking much easier to understand by stripping away the feeling that ports and protocols are just numbers to memorize for no reason. New learners often see a list of names and port numbers and feel like they are looking at a code book instead of something that helps with real support work. The truth is much simpler than that. A port is like a labeled doorway that helps traffic reach the right service on a device, and a protocol is the set of rules that tells the traffic how to behave once it gets there. When you understand what service a protocol supports and what kind of work that service performs, the number stops feeling random because it starts to mean something useful in a troubleshooting situation. That is why this topic matters so much on the CompTIA A+ exam and in real support, because it helps you connect a user complaint to the network service that may be failing behind the scenes. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at CyberAuthor.me in the Bare Metal Study Guide series. The first thing to understand is that devices on a network often do many jobs at once, so they need a way to separate one kind of traffic from another. A single server might provide web pages, email functions, file sharing, remote access, and name resolution, all while using the same network connection to the outside world. Ports help organize that traffic so the incoming request reaches the correct service instead of landing in a confusing pile. If you imagine an office building, the street address gets you to the right building, but the suite number gets you to the right room inside that building. That is a helpful way to think about ports, because the Internet Protocol, IP, address helps traffic find the right device, while the port helps it find the right service on that device. Once you understand that simple split, a lot of port knowledge becomes easier, because you stop seeing numbers as isolated facts and start seeing them as signs that point to what the device is trying to do. Protocols matter because they give structure to communication so devices can exchange information in predictable ways instead of just sending random data back and forth. A protocol tells devices what kind of conversation they are having, what information is expected, and what order things should happen in for the service to work correctly. That means when you hear a protocol name, you should think first about purpose rather than mechanics. Is the protocol helping someone browse a website, send email, transfer files, reach a remote system, look up a name, or receive an automatic network setting? If you stay focused on purpose, you will remember the protocol much more easily than if you try to memorize every port as a disconnected number. For beginners, that change in mindset is powerful because it turns a long study list into a smaller set of service stories that actually make sense and connect to the kinds of issues technicians hear every day. One of the most common protocol families to know is the group used for web traffic. Hypertext Transfer Protocol, HTTP, is the basic protocol used for normal web communication, and it is commonly associated with port 80. Secure Hypertext Transfer Protocol, HTTPS, is the protected version used for encrypted web traffic, and it is commonly associated with port 443. For a beginner, the main point is not just to remember the numbers, but to know what kind of service they suggest. If a user can reach the network but cannot open websites normally, or a browser gives repeated connection warnings, or a web application behaves differently than expected, thinking about HTTP and HTTPS helps you narrow your attention toward web-related services rather than toward unrelated tools like email, printing, or file sharing. Web traffic is such a large part of everyday computing that recognizing these two protocols quickly gives you a strong foundation for understanding how much of modern support depends on simple, reliable web access. Another major group involves remote access, because technicians and users often need to reach systems that are not physically in front of them. Secure Shell, SSH, commonly uses port 22 and is used for secure remote command line access, especially in environments where administrators manage systems from a distance. Remote Desktop Protocol, or DP, commonly uses port 3389 and is used to provide a graphical remote desktop experience, which is closer to seeing and controlling the remote system the way a user normally would in person. The important beginner-level lesson is that these are both remote access tools, but they do not serve the exact same purpose. If someone says they can connect to the network, but cannot start a remote desktop session. That points you much more directly toward RDP than toward web or email traffic. If a system administrator says a secure remote session is failing, that should make you think about SSH instead. Even if you are not the one configuring these services, knowing what they are helps you recognize what type of access is actually broken. Email protocols are another big area because users usually describe email problems in everyday terms without naming the service that is failing underneath. Simple Mail Transfer Protocol, SMTP, commonly uses port 25 for basic mail transfer and is strongly associated with sending mail from one system to another. Post Office Protocol version 3, POP3, commonly uses port 110 and is one traditional way for a client device to retrieve email. Internet Message Access Protocol, IMAP, commonly uses port 143 and is another way to access email, often with a stronger focus on keeping messages managed on the server side. There are also secure versions of these services, such as IMAPS on port 993 and POP3, South on port 995. For support work, you do not need to become an email engineer to benefit from this knowledge. You just need to recognize that sending and receiving are not always the same function. And if a user can receive messages but cannot send them, or the reverse, the failure may be tied to different protocols and different services behind the scenes. File transfer is another area where port knowledge helps because moving files is such a common business task, yet it can happen in several different ways that are not all equal in purpose or security. File Transfer Protocol, FTP, commonly uses port 21 for control traffic and is one of the classic file transfer protocols that learners often encounter in study materials. Trivial File Transfer Protocol, TFTP, commonly uses port 69 and is a much simpler transfer method that is often associated with lightweight network tasks rather than full-featured user file management. Secure file movement can also take place through other methods connected to secure remote access tools, which is why it helps to think about context and not only the number. If a user says files cannot be uploaded to a particular service, you should not immediately assume all network traffic is failing, because the device may still browse the web and send email while a file transfer service has a specific problem. Port awareness helps you understand that the complaint may belong to one doorway on the network rather than to the whole building. Name resolution is one of the most important concepts for beginners because it explains why a network can feel half alive when some parts are working and others are not. Domain Name System, DNS, commonly uses port 53 and helps translate human-friendly names into the numeric addresses that devices use to find one another. Users rarely say there is a DNS problem. Instead, they say the internet is broken, websites do not load by name, apps cannot find services, or some resources work only if opened a different way. That is why DNS knowledge is so useful in real support. If a device has network connectivity but cannot reach resources by name, that pushes your thinking toward name resolution instead of toward total network failure. A beginner who understands that one idea can sound much more confident during troubleshooting because they can separate a naming problem from a connectivity problem and avoid treating every failed website or service as proof that the whole network has stopped working. Address assignment is another service that every technician should recognize because many devices depend on it quietly and automatically. Dynamic Host Configuration Protocol, DHCP, commonly uses ports 67 and 68 and is the service that helps devices receive important network settings such as an address, a default gateway, and often DNS information. Users do not usually complain that DHCP failed. They complain that the device joined the network but still cannot do anything, or that a new device cannot get online, or that only certain systems are having trouble after a restart or move. When you understand DHCP, you realize that a device may connect physically or wirelessly and still fail to communicate properly if it never receives the basic settings it needs. That is why a technician who knows what DHCP does can quickly see that a networking problem may begin before web browsing, email, or remote access ever has a chance to work, because the device may not have received a usable network identity in the first place. Directory and file sharing services are also important because many business networks depend on them even when end users never hear the names directly. Lightweight Directory Access Protocol, LDAP, commonly uses port 389 and is associated with directory services that help systems find information about users, groups, and other network resources. Server Message Block, SMB, commonly uses port 445 and is strongly tied to file sharing, shared folders, and other resource access on many local networks. These protocols matter in support because their failures often show up as access problems rather than as obvious connection problems. A user may say they cannot open a shared folder, cannot reach a department drive, or cannot authenticate to something that used to work normally. That does not always mean the cable is unplugged or the Wi-Fi is down. It may mean the part of the network responsible for shared resource access or directory-based lookup is having trouble. Recognizing LDAP and SMB helps you understand the kind of network service the user is actually missing. Printer support gives you another good reason to care about ports and protocols, because printing problems are common and they often involve network services instead of only the printer hardware itself. Internet Printing Protocol, IPP, commonly uses port 631 and is associated with network printing over modern environments. Some print services also use web interfaces for management, which can tie printing into familiar web protocols as well. The key point for beginners is that a printer can be powered on, visible on the network, and still not function correctly if the service the computer uses to talk to it is blocked or failing. A user may describe that as the printer being offline, when the more exact problem is that the needed network communication is not getting through. This is one reason technicians who know a few common ports and services can troubleshoot more efficiently. They understand that printing is not just a cable and a button. It is also a service conversation, and if that conversation is interrupted, the printer may look fine while the job still never arrives. Another useful protocol to recognize is Network Time Protocol, NTP, which commonly uses port 123 and helps systems keep accurate time. At first, this may not sound as important as web access or email, but time matters much more than most beginners expect. Many systems depend on correct time for logging, scheduling, security checks, and coordinated communication between services. If time drifts too far, strange things can start happening that seem unrelated on the surface, such as authentication trouble, bad log timing, or service errors that are harder to line up and understand. For A+ learners, the main benefit of knowing NTP is not that you will be constantly fixing time servers. It is that you begin to understand that networks rely on supporting services beyond the obvious ones users see directly. A network is not just browsing and email. It is also naming, addressing, timekeeping, and many other background functions that make the visible parts work smoothly. Port knowledge becomes especially valuable when you stop using it as a memory exercise and start using it as a narrowing tool. Imagine a user says the internet is down, but after a few questions you learn they can still browse some internal web pages, their email is not sending, and shared folders still work. That is no longer a general network outage in your mind. It becomes a more targeted service problem, and protocol awareness helps you see which part deserves attention first. Or imagine a remote worker says the connection is fine, websites load, but a remote desktop session will not start. A technician who recognizes RDP immediately has a better starting point than one who treats every network complaint the same way. This is the real value of learning common ports and protocols. It helps you sort problems into service categories so you can think more clearly, ask better questions, and avoid wasting time chasing parts of the network that are still working normally. It is also worth remembering that ports and protocols do not exist to make technology harder. They exist to organize communication so that many services can share the same network without getting mixed together. Once you understand that, studying them becomes less stressful because the names and numbers begin to attach themselves to real purposes. HTTP and HTTPS point toward web services. SMTP and IMAP point toward email. DNS points toward name lookups. DHCP points toward address assignment. RDP and SSH point toward remote access. SMB points toward shared files, and IPP points toward printing. You do not need to become obsessed with memorizing every possible port that exists. For A+, you mainly need to know the major ones well enough to recognize what kind of service is being discussed and what kind of failure might be happening when that service stops responding the way users expect. By the end of this topic, The big takeaway should be that ports and protocols are not random technical trivia, but practical clues that help you understand how network services are organized and where a problem may be happening. A user complaint usually starts at the surface level with words like slow, broken, missing, or offline, but your job as a technician is to connect that complaint to the likely service underneath. When you know the common protocols and their real-world purpose, you can do that much faster and with much less confusion. You begin to hear a problem with web access, email, remote access, naming, addressing, printing, or shared files instead of hearing only a vague statement that the network is not working. That is why port knowledge matters. It gives you a clearer map of what network traffic is trying to do. And once you have that map in your mind, troubleshooting starts to feel organized instead of overwhelming.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.